The study of probability actually owes a lot of motivation to the desire of certain mathematicians to want to do better while gambling. So I guess it's fitting that we have a question in our study of probability about a deck of playing cards. Actually, that's pretty standard fare for studying probability. If you're not familiar with a standard deck of cards, here they are. There are 4 suits, and each suit has one of each of these numbers. Ace is kind of like a 1, up through 10, and then a jack, a queen, and a king. Now, normally when you buy a deck of cards, it comes with a couple of jokers, but we usually don't include them when we're figuring probabilities. Page 203 talks specifically about using tables as a tool to identify sample spaces and solve probability questions. They have a table for you on page 203. I have recreated it sort of here. We're going to answer some questions, starting with number 12. A card is drawn, one card, from an ordinary deck. Use the sample space to find the probabilities. So all of these cards right here, all of them together, that is the sample space. So what's the probability that I draw one card and it's a jack? Well, this column right here are the jacks. There's 4 of them. Now we know that number goes on top, and then the total number in the sample space goes on the bottom. Well, I've got a grid that's got 4 rows and 13 columns. 4 times 13, 52. We could reduce that fraction if we want. We could write it as a decimal or a percentage, or we could just be happy with 4 out of 32, 4 out of 52. Now, what if this question was on a test and you didn't have this table? Here's what I would do in that situation. I would draw a table. But instead of spending all the time of filling in every single square, I would set it up, kind of make sure I had my bearings here. Okay, these are all the aces, these are all the hearts, these are all the diamonds, and so on. I know there's 4 rows here, there's 13 columns here, so there's 52 different cards in the middle, and I'd be pretty good with that. If you think you need every single one written down, then write every single one down. That's fine. Number 13, we were trying to find the probability of a black card between 2 and 7. Now these spades and the clubs are the black cards, so half of the deck is black. But we don't just want black cards, we want black cards between 2 and 7. Now, the question is, do we include 2 and 7? We're speaking just like day to day, and you say between 2 and 7, maybe you mean 2 and 7 in addition to 3, 4, 5, and 6. But in math world, when we say between 2 and 7, we mean we're not including 2 and 7. We're just including the numbers in between. So not 2, bigger than 2, and smaller than 7. But we want them to just be black. So, okay, so it looks like I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 52. Number 14 asks us to find the probability of drawing a card and that card being a 3 or a diamond. So if you win, if it's a 3 over a diamond, that means any type of 3 you win, or any type of diamond you win. So why don't you practice what you've learned, pause the video, answer it, and then hit play and check. How'd you do? Did you get 16 out of 52? which you could reduce. You could reduce to 4/13. Now I'd like to point out that it would be very easy to say, oh, well there are all the threes, there are 4 of those. There are 4 threes, and then I know that there are 13 diamonds, so 4 threes, 13 diamonds, 17 cards, right? Except doing that counts the 3 of diamonds twice, which is one of the benefits of using a table as opposed to just trying to carry it all in your head. So when we draw this, we can say, okay, well I know there's 4 threes, 13 diamonds, but I'm double counting 1, so I need to subtract 1. Or maybe you would say, well, there's 13 diamonds, and then there's 3 extra threes that I haven't already used. However you want to think about it. We end up with 16 cards that qualify for this. Number 15 asks you, why is the sample space in a table form like this useful? So there's 2 ways we can think about it. We just got done talking about using a tree diagram as a chart form. How is a table like this useful in comparison to a tree diagram? Well, let's think about what a tree diagram would look like with a deck of cards. If I had a branch for each suit, there's all the hearts, all the diamonds, all the clubs, all the spades, then each one of those would need 13 little branches off of it, wouldn't it? We know there's 52 different cards, so that would mean 52 tiny little sticks coming off, and it might be hard to just keep that looking neat and tidy, and it'd take a while to draw. Some things work better in the table form. Some things work better in a tree diagram form. How about as opposed to no chart whatever? Well, the question we just did, number 14, gives a great example of how it's easy to accidentally double count something or leave something out. It just helps you be organized. If you have another idea of why a table form like this is useful, that's great. Include it in this answer.